Good day everyone. Let's try to answer some math problem posted on Facebook. So let's start. Here's the question. A circle with a radius 10 circumscribe an equilateral triangle. Then this equilateral triangle circumscribe another circle. Then another equilateral triangle is inscribed in the circle. If this pattern repeats infinitely, what is the sum of the areas of the circle? Now, if you want to try this problem, just pause this video, and if you're ready, here's the solution. First thing to do is to make an illustration. So first, we have a circle. Inside the circle is an equilateral triangle, and inside the equilateral triangle is another circle, then equilateral triangle, then a circle, then equilateral triangle, and a circle, and so on and so forth. Now, our goal is to find the sum of the areas of the circle. To do that, we need to find the length of the radius of each circle. Now, let's focus on these two circles and one equilateral triangle. Now, we know that the radius of the big circle is equal to 10. So, we draw a radius like this, and this is equal to 10. Next, draw the radius of the small circle like this. Now, notice that this angle is equal to 30 degrees. Therefore, we create a 30, 60, 90 right triangle. And the length of the shorter leg of this right triangle is half the measure of its hypotenuse. Therefore, the length of the radius of this small circle is equal to 5. Now, using the same strategy, we can now find the radius of the next small circle. First, draw the radius of the big circle, which is equal to 5. Then, draw the radius of the small circle. And again, we create a 30, 60, 90 right triangle. It follows that the length of the shorter leg is half the length of the hypotenuse. Therefore, the length of the radius of the next circle is equal to half of 5, which is 5 over 2. In this case, we can now see a pattern. Now, the radius of the big circle is equal to 10. The radius of the next circle is equal to 5. The radius of the third circle is equal to 5 over 2. And the radius of the next circle is equal to 5 over 4, and so on and so forth. Now, our goal is to find the sum of the areas of the circle. Now, to find the area of the circle, we have the formula pi r squared. So, the total area of the circle in this diagram is equal to pi times 10 squared plus pi times 5 squared plus pi times 5 over 2 squared, and so on and so forth. Now, factor out pi, we have 100 plus 25 plus 25 over 4, and so on and so forth. Now, notice that this sequence is what we call infinite geometric sequence, and the sum of the sequence is given by the formula a over 1 minus r, where a is the first term and r is the common ratio, wherein r is between -1 and +1. Now, using this formula, we have pi multiplied by 100 over 1 minus 1 over 4, simplify, and we get the sum of the areas of the circle, which is equal to 400 over 3 pi square units. And we're done.